How do earthquakes on fault lines displace homes? Imagine the ground suddenly shifting beneath your feet, like a giant hand grabbing the earth and moving it in a quick, jarring motion. That's what happens during an earthquake on a fault line. Fault lines are cracks in the earth's crust where two blocks of land slide past each other or move vertically. When stress builds up enough along these faults, it causes the rocks to break and slip suddenly. This slip is what we call fault rupture, and it's the main reason homes can get displaced during an earthquake. When the fault slips, the surface of the earth can crack open or shift sideways. The area right along the fault line, called the rupture zone, experiences the most intense ground movement. If a house sits directly on or near this zone, it can be torn from its foundation or pushed sideways. Sometimes the ground moves vertically, causing a house to sink or lift. Other times the movement is horizontal, making structures slide along the ground. In some cases, both types of motion happen at once, twisting and cracking buildings. The size of the earthquake matters a lot. Bigger earthquakes with higher magnitudes cause more fault slip and larger surface ruptures. For example, a quake with a magnitude of 7 or higher can cause several meters of displacement in the ground. The type of fault also influences how homes are displaced. Strike-slip faults mainly cause horizontal shifts, while reverse or thrust faults push the land upward or downward, often causing more damage to structures. How close a house is to the fault line makes a big difference. Homes right on the rupture zone are most likely to be severely damaged or completely displaced. The farther away, the less impact there is, but damage can still happen from the shaking itself. Local ground conditions also play a role. Loose or water-saturated soils can amplify the shaking, making the ground move more violently and increasing the risk of displacement. Buildings that aren't built to withstand earthquakes are especially vulnerable. Homes with weak foundations or poor design can crack, tilt, or even collapse when the ground shifts suddenly. Signs of displacement include cracked walls, misaligned doors or windows, and uneven floors. Sometimes, the ground itself cracks open, revealing the fault line and showing how far the land has moved. Secondary effects like soil liquefaction can worsen the situation. Liquefaction happens when saturated soils lose strength and act like a liquid during shaking. This can cause entire houses to sink or tilt or even topple over. Landslides are another danger, especially on steep slopes near fault lines, which can push or pull homes downhill. In the end, when fault lines slip during an earthquake, they can cause homes to shift, crack, or fall apart. Understanding these movements helps engineers design stronger buildings and prepare communities better. It also reminds us why living near fault lines requires careful planning and resilient construction.